Good morning, all. Okay, I will start our fifth sem subject, that is signals and system. I will be handling of signals and system for fifth sem students. Okay, our college is Prodera Institute of Technology. Okay, what do you mean by a signal? Signal is a function of one or more variable which conveys the information. A signal, it should convey some information and it should be understood. Then only we can tell that it's of a signal. Okay, for that reason, which conveys the information, that is very important. One or more variable. If it is going to vary with one variable, then we can tell as one-dimensional signal, that is of a speech signal, and two-dimensional signals means it's going to vary with respect to x and both y-axis, that is of a image. I can give the signal example as a image. Next, some more examples I can give in terms of electricity, that is in terms of current and voltage. Okay, audio, images, video, radar signals, and also of a seismic signals. These are all two examples of a ECG signal and also it's a image. This is a example of a signal. If I come for the system, a system is an entity that manipulates one or more signal that accomplish a function, thereby yielding a new signal. For a system, I'm going to provide an input and I'll be getting an output. Here the system is going to process the input and it's giving a different output. That's what yielding a new signal. Okay, it's going to manipulate one or more signal and giving a completing of the function and it's going to give a new signal. That's what a system. Here system stores, manipulates, and transmits signal by a physical process. It may be anything. Here some of examples given. Automatic speaker recognition system. In your Google, if you just talk, if you want any listening of the song or else to share with the location, which one you want to know the location, you can do of that by using of a system. In communication means your mobiles. In aircraft landing means we have to check what is the weather, what is the humidity, or else what is the temperature, and also what we want the weather forecasting signal. Based on that, your plane is going to land there. For that reason, we need of a signal, how it's going to work for a signal and also a system. That is of aircraft landing system. Then electric circuits and systems. In your see, you'll be doing in AEC. You'll be doing of some experiments where you are going giving the inputs as a current and voltage and you will be getting output as a sine wave, square wave, anything. Okay, in such applications we are going to use of your signals and system. Then control systems and signal processing. Control means your robots, signal processor means in CPU how it's going to work. Okay, those are all signals and systems. Next, some examples in automobile industry. For a vehicle, how much the speed is going for based on your acceleration and braking effect. In automobile, how it's going to, if you are going to speed, you are going to give pressing of accelerating. If you want to stop means braking. Automobile industry, we're going to use of your signals and system. Next, in electrocardiogram, in ECG signals, we have to test what is the patient's heart rate. In such applications, we are going to use of your signals and system. In control system, control unit, I can use, or else we can use of your robot to which direction it has to move and which arm it has to lift. Like those applications, we want our signals and system. Next, major applications are going to be taken here as communications, audio and speech processing, image, video processing, acoustic, circuit design, seismology, biomedical engineering, bioinformatics, energy generation and distribution, chemical process control, and aeronautics. These are all major applications of signals and system. Next, classification. They are classified in 5 different types: continuous and discrete time signal, even and odd signal, periodic and non-periodic signal, deterministic and random. Last one is of energy and power signal. In a continuous and discrete time signal, here example is given where it's going to change with respect to time. A signal is going to change with respect to time, we call as a continuous. Here it's going to change in terms of a discrete values. Signal is going to change in terms of a discrete with respect to time. That's what continuous and discrete time signal. Here an example. Yeah, continuous time signal is going to be converted to digital values. Before, first we are going to use of sampling theorem. That is a Fs is equals to 2 times of Fm. We have to satisfy that condition. We'll be converting analog signals to a digital and then quantizing. In this case, we are doing the conversion. That is with respect to time. What is the time period? We can check. Here is of number of samples, that is n. At what time period it's going for? Ts. And output what I am going to get, that is x of n is equals to x of nts. With respect to time, I will be getting my digital values. This is one example. I can do of two methods here. First I can sample and then quantizing, or else quantization and then sampling. We can go with the any method. To do the conversion, we can use of analog to digital converters. Okay. This is one example of ECU signal, how a continuous signal is going to be converted to a digital values. Next, even or odd function. A signal can be told as a even when it satisfies the condition x of minus t is equals to x of t for all of t. Even signals are symmetric about vertical axis. Observe the figure here. The signal is going to be symmetric about vertical axis. This same signal is going to be taken here. This is about symmetrical about vertical axis. Then odd signal x of minus t is equals to minus of x of t. Means negative values you will be getting. Odd signals are antisymmetric about vertical axis. This is about antisymmetric. It's here is a positive value. Here is of a negative value. Okay. This is about your even and odd signal. To find even function and odd function, here the equation, that is 1 by 2 x of t plus x of minus t. X odd of t is equals to, this is for odd, 1 by 2 x of t minus x of minus t. To get this equation, first we have to take a signal where it is consisting of both even function and also of a odd function. Okay, then I will do x of x e of minus t is going to be, if it is of even, it's going to give a positive values. For that reason x e of t. For odd values, x o of minus t is going to give the negative values, that is minus x o of t. Then putting t is equals to minus t in the equation first, this equation. Okay, if I substitute, I'll be getting x e of minus t plus x o of minus t, that is equals to, then if I solve here, x e of minus t means x e of t, x e of minus x o of minus t means minus x o of t. Solving for equation, then I'll be getting of how to solve this equation to get x e of t and x o of t. Solve first equation of x of t and x of minus t. First you add x of t plus x of minus t. Then you'll be getting of even function as 1 by 2 x of t plus x of minus t. Then x of t minus subtract. Do the subtraction here. X of t minus x of minus t. You'll be getting your odd function. X o of t is equals to 1 by 2 x of t minus x of minus t. You'll be getting like this. You'll be getting the equation. This is very important. Okay. Next is of periodic and non-periodic signals. Here periodic signals means it should satisfy the condition x of t is equals to x of t plus capital T for all t, where t is a positive constant, that is time period. Okay, f is equals to 1 by t. We learned of this equation. F is equals to 1 by t. Angular frequency is going to be omega is equals to pi f, that is equals to pi 1 by t. Here the example, a sine pole 1 cycle is taken as the time period taken to complete 1 cycle is taken as a t, capital T. The signal is going to repeat again repeating with respect to time. Here is examples are given. A sine function, the same one whole cycle is going to repeat further. Again for a square, again for the triangle, and again for the sawtooth. These are the example for periodic. In non-periodic, where it is not satisfying the condition of x of t, not satisfying means x of t is not equals to x of t plus capital T for all values of capital T. This is in terms of a continuous. In terms of discrete means, continuous means x of t, discrete means x of n is equals to x of n plus capital N for all values of n. If it is satisfying the condition, then it is a periodic. If it is not satisfying the condition, it's not equals to means it's a non-periodic. What is the fundamental frequency of discrete time? Omega is equals to 2 pi by n only. In the continuous time, it's of a capital T, here is of a capital N. This is an example of aperiodic. Observe here, analog signal. It's always varying with respect to time. Here, with respect to time, it's changing. Observe here. Okay. This is the example of here, periodic and non-periodic. Next, deterministic and random signal. Deterministic signal is a signal about which there is no uncertainty with respect to time. Means a signal is not going to change with respect to time. Examples are going to be taken as square and rectangular pulse. It's a rigid one. It's not going to change with respect to time. Okay, like a pulses. A random signal, name only telling, a random signal is a signal about which there is uncertainty with respect to time. Means it's going to change with respect to time. Examples are electrical noise generated in amplifier of a radio and television receivers. You can give any noise. If there is a noise means there is an uncertainty. Okay, this is about your decision and random. This is an example. Observe here. A samples, it's a going to change in a one particular rule, but in a random, it's not in a, it's going to be randomly spaced each sample. Okay, this is what the example. Next, energy and power signal. In electrical systems, a signal may be represented in terms of a voltage and also in terms of a current. What is the power equation? P is equals to V square of T. With respect to time, if I am telling, we are going to use of a T, V square of T divided by R, or in terms of current means I square of T into R. When R is equals to 1 ohm, then in terms of signal, I can write as P of T is equals to X square of T. In terms of voltage and current, in terms of signals means X square of T. This is an example of a energy signal, triangular signal, and this is the example of a power signal where it's going to vary from minus infinity to plus infinity. Okay, these are all the equations in terms for a continuous time and also for a discrete time. In terms of continuous time signal, total energy I can write as E is equals to integration minus infinity to plus infinity x square of t dt. Here total power P is equals to 1 by capital T integration minus t by 2 to plus t by 2 x square of t dt. Total energy E is equals to summation minus infinity to plus infinity x square of n. In continuous, it's of integration. In discrete, it's of a summation. And total power P is equals to 1 by capital N summation n is equal to 0 to n minus 1 x square of n. These are the equations you have to remember. Okay. Here, given some points how energy and power is dependent. Energy is having a zero power and power is having a infinite energy. Okay. Periodic and random signals, if it is there means I can tell that is of a power signal, and a signal is having non-periodic and deterministic, I can tell that signal as a energy signal. Remember these points so that it will be easy to identify whether it is a power signal or as a energy signal. Periodic and random means power, non-periodic and deterministic means energy signal. These are all the classification of signal. Okay, we learned of all the classification. Once a small revision, we done with continuous, discrete, even and odd signals, periodic and non-periodic, deterministic and random, energy and power signal. Okay.